Sir, we are live now. Please start.
Okay, can I start?
Yes, sir, please.
Okay. Hello, everyone. Good afternoon, good morning, good afternoon, and good evening, depending on where you are. So today we will be talking about modern IT service management using AIOps. Before we get into the topic, I will quickly introduce myself. My name is Naveen. I am an executive architect IBM, and I am with IBM for about 21 years now. The areas where I specialize include cloud computing, IT service management, and some other related aspects. I will move on to the next slide. So this is a disclaimer. I work for IBM, so this is a disclaimer. Okay, so before we get into what is AIOps and why AIOps is important for IT service management, I thought it will be important we go through the evaluation of hybrid multi-cloud scenario and the complexity that is introduced. So if you look at the left-hand side of the screen, you can see a traditional or a legacy IT environment, which normally involved a data center at a specific location. And at the max, it had virtual machines running on physical machines, or sometimes workloads are deployed directly on the physical machines. And the usually a monolith application. If you do not know what is monolith application, just think of it as an application where all the logic of the application is packed into a single module rather than splitting them into smaller components which can be independently managed. So this was the scenario if you look at a traditional or legacy IT environment. Now what we are seeing from a modern IT environment perspective, if you look at the right-hand side, there is a variety of environments where you can deploy workload today, and there is a variety of form factor through which you can deploy workload. So if you look at from the bottom half of the slide, public cloud environments like IBM Cloud, AWS Cloud, Microsoft Azure Cloud. So this is an example where now we can deploy workload. So in this scenario, it is no more at a client's premise. It is on the public cloud environment, and they connect to it using internet connectivity. Private cloud is another example, a deployment model. It could be either in the physical data center that is owned by a client or a consumer, or it could be created as a virtual private cloud on top of a public cloud. And the third scenario that we see is a hybrid. So it could be a combination of public cloud and private cloud. It could be a combination of public cloud and traditional IT. So we are seeing multiple scenarios here. And even in the public cloud scenario, we see nowadays clients utilizing more than one cloud service provider. Cloud service provider A may be having very good capabilities when it is coming to, say, data management. On the other hand, another cloud service provider may be having superior capabilities when it comes to certain other type of workload. So clients use a combination of different public cloud environments because of this as one reason. The other reason we see why clients are using different cloud environments is to get some sort of redundancy. They do not want to bet only on a single cloud provider and have something like an outage happening to that single cloud service provider. They don't want to suffer. So there are a variety of reasons why we are seeing a hybrid multi-cloud ecosystem. And the final thing is the edge computing. This could be something like sensor devices, which are collecting data and sending to its central environment, or it could be even the, say, edge location or the remote location of a company where they have a very small IT infrastructure and it is subsequently controlled through a centralized IT system, right? So these are the variety of deployment models we see. Now, if you look at the form factor, the very next layer on the top, on cloud also, we continue to see certain workloads demanding bare metal systems, sometimes bare metal systems with specialized CPUs, especially for things like big data and analytics type of workload, and of course, virtual machines. And the other important thing that has become very important of late is containers and serverless computing. So in case of containers, it is a more thinner package compared to a virtual machine. And in case of serverless, it is more like functions as a service. So you go and define a function that you want to use. You do not get complete access to a virtual machine or at an operating system level. And now the final layer on the diagram shows the different type of application workloads that is getting deployed or delivered using the deployment models and form factors that we just discussed. So monoliths continue to be deployed on cloud environment. There are several examples. One simple example is, look at the left-hand side. A client is having a traditional IT environment, and now they want to move to cloud. And their primary objective could be that as soon as possible, I want to shut down my data center. I want to save cost, and now I want to go to cloud. So in such case, instead of immediately spending time to modernize their application, the monolith, they will do a simple lift and shift onto the cloud. And then later staying on the cloud, they may modernize or they may not modernize depending on the specific technology that is used and what is thought as the longevity of the application and so on. And the other important paradigm that we see, or a programming model that we see, is microservices, where instead of deploying the entire application business logic as a single monolith application, it is split into manageable smaller modules, and they can be lifecycle managed separately. So think of a very simple example, an e-commerce site where you may need to have a catalog management function to display what can be purchased or displayed through the site. And then there will be a cart management service, and there will be a order or a payment management service. So in a monolith scenario, all those three things will be part of a single block. And if you need to consider scenarios like there are several people who could be browsing the catalog, but there may be very less number of people who are actually performing a check-in and buying something, right? So when several people are browsing the catalog, you may need to have a capability where you can independently scale that module alone instead of providing computing power for the other modules where there's not traffic. So that is a example why microservices become important compared to monolith, where in microservice scenario, the catalog management can be one independent module, the cart management can be another independent module, and the payment can be a third independent module. And if you see more traffic for the catalog management service, that can be scaled up independent of the other two, and the computing that you assign for that particular service will be only for that. So that brings even financial optimization. Now, the other two mod that we see is software as a service model and mobile application. Mobile applications also most of the time connect to a central system, often deployed on a cloud, and make API calls to deliver the service that an end user is trying to consume. In the software as a service model, it is like everything is managed by a service provider. The consumer often just go and consume that business function. Email as an example, many of you should be using Gmail as an example, right? So if you look at Gmail, you simply go there and consume email as a service. You do not host your own infrastructure to host that service. So that's an example of the SaaS. So now what is happening as part of this evolution is, let us look at the next slide, right? From a consumer or developer perspective, things are becoming simpler. But on the other side, from a IT service management perspective, the complexity is now increasing. And if you look at the slide, the middle portion, you can see what is a typical vertical view of a IT solution. You will have a data center component, network component, storage component, bare metal component, hypervisor, which is a facility used to virtualize compute, storage, and network functions. And then you have the virtual machines, operating system. Sometimes there is a container, sometimes there is no container, application, data analytics, and business process. Now, in a legacy environment, several of these things did exist, but there is only one such stack. But in the modern IT environment, as we went through the previous slide, there will be several such stacks like this, with varying levels of complexity and accountability. For example, in a software as a service scenario, this entire vertical stack that you see in the middle is usually managed by a service provider and consumer does not have any responsibility. But on the other hand, if we look at an example where a client is consuming something like infrastructure as a service, then often right from the virtual machine layer all the way to the top, the client need to manage. Now, irrespective of who does the management, the full vertical stack needs to be managed. It needs to be monitored to see if there are problems occurring. And then depending on the signals that we get through that monitoring, which we call as observability, we need to take appropriate action to resolve problems if something has already occurred, or we need to proactively solve problem wherever we are able to get such notification in advance, right? And the complexity in the modern IT environment is you will have several such vertical stacks in parallel that forms a final business solution. So now you need to manage it, right? And I've given an example here. If you look at the infrastructure layer here, all the way from data center to operating system, there has to be infrastructure monitoring, and that monitoring function will be delivering certain events. For example, CPU utilization of a system has crossed 90%. Somebody should take an action, otherwise that system may crash, right? Similarly, at the application level, we need to perform monitoring and it will generate respective events. Here it could be something like a transaction is running for a longer time than expected, and there is a scenario of something timing out. And similarly, from data and analytics perspective, the quality of the data needs to be analyzed. And finally, the business process behavior, right? And now, if we are expecting an IT service management team to handle the flood of these events that is coming on their way, it becomes impossible for them to manage in a very complex environment. And they will get overwhelmed, and often they will be always firefighting to handle such events. And if you see the note here, we need to have a better system to proactively catch such events. We need to correlate such events so that we are eliminating what we call as the white noise or the flood. There could be 100 events coming from an environment, but it may be related to the same problem, right? For example, if you look at this entire stack, vertical stack, if there is a problem with the physical machine, which is denoted as bare metal system here, anything above that will obviously fail. And all the horizontal layers in the solution, because there is a monitoring configured, will start generating monitoring events. But if we have an intelligent facility which understands this and automatically correlates and duplicate those events, then we will have a single actionable event and we just need to worry about that. So that's where the artificial intelligence or machine learning capabilities are coming to help us, right? And I just wanted to set the context here before we get into what is AIOps and why it is important. So hopefully this context helps in a IT service management. Why do we need a better facility, right? Now let us look at some of the different ways of handling problems in an IT environment. So one of the common scenario is fix problems after a user report that problem. And because the issue is addressed after a user is reported, often it takes long time to solve such problem, long time to even understand that there is a problem and then eventually solve the problem. The next one is fix problems as soon as we understand that users are affected. And how do we know users are affected? It is through monitoring. If a monitoring system senses notification, it will tell us that, okay, there is certain users now impacted. And even before a user come to a IT service management team, that team can now start taking action to resolve the problem. But even in this scenario, it is still a reactive approach because we are solving the problem after it has occurred, right? But now what we need to do is we need to avoid issues before they happen. And that's where we need a better monitoring system, better machine learning capabilities to identify the patterns of system behavior and then detect what we call as anomalies from the system. So as an example, I spoke about an example of a system having CPU utilization 90% and somebody is getting a notification. Now, in that case, why are we getting a notification? Because somebody went and configured a static threshold called 90%, and whenever it is breached, there is an event generated. But today's workloads are not very static; they are very dynamic. Especially if you look at containers, the average lifetime of a container compared to a virtual machine is around 3 minutes, where a virtual machine could be up and running for 30 days, maybe even 3 months without a reboot. But in case of container, the average lifetime is 3 minutes. After that, you will see that getting killed or getting restarted, another instance coming up, you will see all such behavior. So given the dynamic nature of systems, it is impossible to bet on static threshold. So that's one example where machine learning comes into picture. And what happens in this kind of scenario is using the historic monitoring data, machine learning using certain algorithms, understand the behavior, and system is now able to predict what is a normal behavior of the system, what is the abnormal behavior. And as soon as it starts seeing a change in the pattern, for example, let's take a simple example, the number of concurrent requests coming to an application, any application, it could be google.com or any application, right? Let us say that is increasing beyond a normal observed value. Now, there at a high level, there are two reasons why this is happening. It could be a legitimate traffic. Maybe there is something going on like a sports event and many people are now trying to search for score or anything like that. Or sometimes it may not be legitimate. It could be an attacker trying to launch the dynamic denial of service, DDoS attack, right? So nevertheless, that rise in the number of concurrent requests is an anomaly according to the system, right? So it will learn that automatically. It will generate an event. Now, once we get the event, we can take a decision based on the context. So, okay, should I take an action? Do I think this is a legitimate traffic? And if I think it is a legitimate traffic, okay, let me go and add more capacity to the system so that it continue to perform at the same level and so on. And the final thing is make changes also proactively. So AI can also give us predictions, and AI can also give us prescriptions. So prediction could be the example that I mentioned. Okay, there is anomalous behavior. Now, depending on whether that anomalous behavior is a positive thing or a negative thing, from the AI system can be used to handle that positive situation or to prevent that negative situation. So that's a value we get when we introduce machine learning, because it requires analyzing large amount of data, and doing this manually becomes impossible, especially in a small amount of time. So hopefully that start to give you more and more context around AIOps and why it is becoming important. Now let us take a real example, right? So if we do not have AIOps, and by the way, AIOps is a concept where artificial intelligence and machine learning capabilities are used for the IT operations and IT service management. So that branch of machine learning and AI, which is specifically focusing on this, is called AIOps. So it's a concept, it is a practice that can be leveraged, and there are several tools and products around this. What you see on the screen now is a scenario where we do not have AIOps. So normally there are various phases in the lifecycle management of a problem. We need to first detect the problem. We need to isolate the problem. We need to diagnose and find the root cause. We need to fix. We need to verify. And what you see here is our industry numbers based on our experience. So normally when an event comes, to go and detect that problem, it may take around 1 hour. And this detection includes the correlation that I mentioned, if you were to do it manually, right? And often it takes much more than 1 hour also. Then we need to isolate by performing deduplication and certain other steps, like such as fact finding around that environment. Okay, so one of the simple example of fact finding is, was there any change made to that environment in the recent past? Because often in a stable environment, a change is what causing problem. So that's an example of isolating the problem. And then we need to diagnose, find the root cause, go and fix. So you can see the numbers here. Now, when we introduce machine learning, it becomes something like this, right? The detection, isolation, diagnose all drastically reduces. The fix today, it takes some amount of time, and the verification also takes amount of time, because to verify, it is not just the person who fixed have to verify, but the end consumer also need to verify. So there may be a waiting period for somebody to come and test the system and so on. But the AIOps concept and the related technologies, algorithm, everything is rapidly evolving. So don't be surprised if you see tomorrow, you see this time shrinking even further. So continuing now, is this a concept at this point, or is it really getting practice? So the reality is it is really getting practice, and based on our experience working with several clients, this is what every client now want. And especially with the COVID pandemic, there is even greater focus on cloud computing. Say, for example, we all are working from home currently. The offices are not yet open. In a scenario where we are working from office, most of the traffic that is generated from our laptop or any other system, most of the time it is confined within our organization. But now, because we are at different places, we need to be on several meetings and so on. All this traffic is coming over the internet from our system. So there has to be even more focus, and the speed of detecting problem and isolating problem is important, because the threats are also increasing when things are moving to cloud computing, right? Okay, so let us look at some of the details around AIOps, right? What value it provides. There is some animation, let me finish it. So if you start from the left-hand side, one important point is the lack of observability and siloed thing, which I explained in the previous slide, where the events are coming from different layers of a system. And if you don't have a facility to correlate them and group them together, our observability is limited to what we see. Until we go and perform analysis, we don't know that the issue that is reported to me is also the same issue that is reported to one of my colleague, right? So that there is a human dependency to go and do that analysis. But if you bring the AI capability, we can do that correlation in real time and do the deduplication. The other thing is providing a prediction of what might happen, the anomaly detection example that I mentioned. And the third thing is providing a prescription to solve that problem. And in many cases, have the ability to prevent the problem from happening itself, right? And there are many things around this, such as DevSecOps practices. It is both a culture and technology aspect along with process. I do not know how many of you are familiar with many of these concepts. So I'm keeping it at abstracted level, but if there is more interest, we could even have a separate session later. We can go more deep into some of these things, including we can look at some of the frameworks around this. And what are the key things that normally consumers expect from an AIOps solution? So it has to be domain agnostic, which meaning, again, going to that vertical stack as an example, right? If you have an AIOps solution that knows only to work with infrastructure layer of a solution, but does not know how to work with the application layer of a solution, that still introduces or maintains a silo. So we need to resolve that. The other thing is it has to support the digital transformation through which the companies are going through, which means it also need to have a business process knowledge, not just IT process, because often when there is a problem in the business process, it may be related to IT components that is supporting that business process. So it has to be correlating with that. The anomaly detection part, we already spoke about that, so I'll skip. And then we also talked about the prescriptive advice and remediation action, and AI generated automation, AI executed automation. These are some of the things that we are practicing, where based on the past example or past operating procedures of an engineer, if he ingest that data into an AI system, AI systems are not able to read that standard operating procedure and generate an automation. It could be a script, it could be an Ansible playbook, doesn't matter. It is a program. It is able to generate a program and it can go ahead and execute that automatically in many cases. So that's where we are leading. So you will see the root cause analysis and resolving a problem even shrinking with this becoming more and more matured. And what are the key elements of an AIOps strategy? So we typically start with a simplified approach of discovering what is there in the environment, and then start from there and look all the way to proactive capabilities, right? Proactive capabilities will be supported with predictions that is coming from the environment. And then using those prediction, we can develop certain prescriptions. So monitoring and observing is very key because there is no AI without data. And that data will come only when we have a monitoring system in place, which will be sending what we call as telemetry information from a system. And this telemetry include things like metrics, events, logs, and traces coming from environment. So metrics could be something like CPU utilization. Logs, I'm sure all of you know the logs that is getting generated whenever there is a certain steps that is getting executed, whether it is success or failure, that log will play important role. And most of the time, if there is an error code that is there in the log file, we need AI system to trap that error code and then take a subsequent recommended action. And tracing is a technique where when there is a process that is getting executed through a system, how can we trace the progress of that process from one step all the way towards the end through the various components that is included in the execution of the system. So we will know, say for example, component 1 and component 2 is involved in the execution of process. Component 1 took 2 milliseconds, component 2 is waiting or it is taking 10 milliseconds. Then we know there is an issue that is happening here and the monitoring system can catch and compare that with other monitoring statistics coming. The predictive and reactive application impact avoidance, which will leverage the data that is coming from the monitor and observe phase and apply machine learning algorithms on top of that and start providing predictions, and either to solve a problem that has already happened, explaining based on the past behavior, these are some of the steps that we have been taking, right? Or it could even say that based on the data that I see from monitoring system, there is a likelihood of an issue occurring in next 10 days. It could be a linear analysis, for example, right? And proactive issue avoidance leverages this prediction, and then depending on that, whether that prediction is positive or negative, it will give the steps to either go and achieve that positive outcome or go and prevent that negative outcome. And one final thing, which is also related to AIOps or application of AI in IT service management, is cost management and efficiency. There is a separate branch, which is now popular with a term called FinOps, financial operation. And what happens there is in a cloud environment, I'm sure many of you would have at least got a taste of some form of a cloud environment. In a cloud environment, whatever you deploy, there is a cost, right? And often it is charged per hour or sometimes per minute. So it will be good if we have an AI system, it is able to read again historic data and suggest that based on the utilization trend, in the night you are never using the system. So I can provide your runbook, which is nothing but a steps which you can follow and stop your service, so you will not incur additional charges. Or in a running environment, a optimization report can be provided by the AI system explaining if you take these steps, your monthly bill can be reduced, right? So that branch of focus with respect to IT service management is called FinOps. Moving on. So what is the typical journey that clients will take? And by the way, there is no one single solution for every client. It really depends on what is the current state and context of the client. But in general, depending on the maturity, we can start from the left-hand side and go all the way to the right-hand side. So often it will be good to go and understand what is already there in the client environment. So that will be a discovery process, and see if you have good monitoring in place. Because if you do not have monitoring, then you are not seeing what is happening and you are not collecting data, which is really important for us to establish an AI-based system or an optimized IT service management system. And after that, we will start identifying certain issues which is repeating, and then we can either go and find out why an issue is repeating and see if it can be permanently resolved, or at least create a automation that can be executed when that issue happens so that it can be resolved faster, right? And then we can keep working on permanent resolution. And then it is getting into more advanced things like anomaly detection, self-healing, and autonomous systems. So in an ideal scenario, you will have a system that is running itself. There is no human required to manage, but that is, at least today, is a real ideal target. But the key is, even if we manage to reach 60 to 70% closer to that, I think we'll get a lot of optimization and a lot of value. And one other thing I wanted to call out here, similar to FinOps, there is another practice associated to AIOps, which is extremely important. That is called site reliability engineering. It is a concept pioneered by Google, and it is now widely adopted in the industry. So in the site reliability engineering, the focus is to permanently resolve problem. And the way Google says, it is to apply a developer mentality into IT operation issues. So the traditional system administrator concept is dead or it is dying. The future is we need to have site reliability engineers who can take a holistic view of the solution from a non-functional angle. When I say non-functional, it is focusing on things like performance, availability, and such aspects of a solution. And they will even have the ability to go and make code level changes into a solution so that they can add more value and they can fix problems, which also means that they'll be bringing a different type of skill set onto the table compared to a traditional system administrator. So that's an extremely important area related to AIOps, because if you look at this area, for example, where we are finding root cause, either we need to go and solve it permanently, or we need to create automation to solve that problem. Before we get the next level of maturity where AI itself is able to create that automation for us, we will need some humans to still go and do that. And there we will need the site reliability engineer skill. And if you look at the bottom left of the chart, when we start the journey, typically we see it is reactive, manual, fragmented, a rule-based approach for correlation of events, and a lot of silos in the environment, right? But once we move towards the right-hand side, it becomes more proactive, automated. It's not fragmented, it's not silo. We are getting the holistic view of the IT environment, and it's not no more rule-based. It is all AI-based grouping of events. So here, what you are seeing is two different approaches for delivering the AI-based solution. One could be a longer process where we are not training the AI models upfront. We are always collecting data and cleansing the data and then choosing the right algorithm depending on the scenario. Then we are creating the machine learning model. We customize it, we experiment, we train, tune, and then deploy into production. That's one approach. The other approach is we create pre-trained models and deploy into an environment. Often only tuning is needed. So as you can see from the length of the horizontals, the pre-trained model always have the advantage of giving you the value much faster because you just need to perform a tuning. If you take some of the tools available in the market, there are tools, it can take 2 weeks worth of data and start learning about the environment and start giving you anomaly detection type of output. Some other type of tools probably need 4 weeks worth of data. On the other hand, sometimes there is advantage of using the model which is developed contextually very specific to an environment, because there is no product in this world it can solve every issue in a IT environment, in a real IT environment, because every environment is different. So always there is something really contextual to that environment. So sometimes there will be a need to create an extension of our pre-trained model which will be a field trained model depending on the specific data in a client environment. And once we get maturity with many such models, that learning can be fed back into a product, and now it can become a pre-trained model. So today, if you ask me, I don't think it is not either or scenario. It is a hybrid that's going to give us good value. But as the capabilities in the space increase and more patterns are detected, I think the trend will be towards a pre-trained models. And what will be the functional view of a typical AIOps stack? So if you start from the bottom half, the main thing that is feeding into the solution is knowledge about the environment. So it could be IT data, it could be business data, it could be security, it could be anything, right? Now, once we have the data, the next step is to make sure it is integrated into an AI system. And then the AI system is analyzing the type of data that we are getting. It could be curated, structured data, it could be semi-structured, it could be totally unstructured. So we have to deal with different type of data, right? For example, if you are looking at something like metrics, it's a structured data. But if you're looking at something like log, it's an unstructured data. So we need to deal with a different type of data. And once we have the data, we need to detect patterns out of it and then provide their predictions and prescriptions and also act on it automatically. And then the final layer at the top is very important. It is the visualization, which is actually providing visualization, not just about what is the health of my system, but it is also telling what is the health of the automation that is managing my systems. So both are very important. So as you can see here, one will be the observability of key metrics, analytic reports, remediation result, and also the status of the automation and the AI itself, right? And on the left vertical, what you see is learn and optimize, which is a very, very important thing, because an AI system should be able to learn itself as we progress. And this is called supervised learning or retrospective learning. Here, the focus is to make sure based on what happened on a prediction that I provided. So for example, the AI system detected an issue in the system. It has given a prescription saying that if you execute this program, you can solve the program, and the user might have executed that program. It might have resulted in a positive outcome, or it might have resulted in a negative outcome. So that feedback is important from the user. And based on that feedback, the AI system can learn itself. And the next time it will give more intelligent prediction with better confidence rating. And one final slide here, this is giving you what is a real view of a scenario. So I have taken an IBM product here as an example, but it could be any product. So what is the IBM product in this space? It is called IBM Cloud Pak for Watson AIOps. And if you start from the left-hand side, what you see on the left-hand side is that vertical that I explained earlier, the typical vertical view of IT solution. But it is highly abstracted here. So you can see there are network functions, the complexity of hybrid environment, and there could be edge components like sensor, mobile devices. And there is data coming from all these components, and data is coming at a rapid pace at every minute. And this data that we are seeing could be logs, it could be ticketing data, it could be metrics, it could be topology information, it could be alerts and events. Now they are processed through various processes or algorithms like log anomaly detection, natural language detection is important. Natural language processing is important because using NLP, you can understand what is the problem an end user is reporting, and then you can automatically decode the domain of that problem and correlate that with metrics and topology information, events coming from the environment. And finally here in this system, this is more of heart of the AI. Here, all that correlation and prescription prediction, everything is happening. Now, depending on what is coming from here, it could be a ChatOps process. So this is another peripheral concept, ChatOps. In ChatOps, what happens is you are inviting a group of people into a collaboration space like Slack, Microsoft Teams. I'm sure all of you are using these kind of tools. So you're inviting several subject matter experts into a collaboration space like that, and they collaborate and solve the problem. So think of it as a digital war room or a virtual collaboration space where they can collaborate and solve the problem. And one important thing is that collaboration space can be enriched automatically by the AI system with certain recommendation, and all the conversation that is happening there can be retrieved back by the AI system, and it can apply a retrospective learning on that to improve itself, right? And the other thing that is important here is the AI-based dashboards, which is providing visibility around what is happening in the environment, what is the status of the automation, and so on. And the third thing is runbooks, which is nothing but a program. Often it is an automated program, which is automatically executing a standard set of procedures that one would have taken to solve a problem. So instead of depending on a human, if depending on the grouping and prescription that we are generating at the heart of the AI system, it could go and directly execute a program so that without involving a human, we are able to solve the problem. And this could be in the form of a robotic process automation, or it could be a runbook automation. So robotic process automation often deals with, simply said, automating mouse clicks, because there may not be a programmatic way of executing commands. There may not be a CLI or an API available in certain traditional system. The only way could be to deal with a thick client, and it may be only accepting mouse clicks. So that's where we bring robotic process automation as a simple example, something like filling a form, reading a spreadsheet, and so on. And on the other hand, the runbook automation is really a program which is leveraging CLI and APIs provided by target systems and executing steps against that programmatically. I was thinking that I will provide a quick demonstration of this in action, but I think we are running short of time. So I will stop here because I do want to spend some time on any question that may be coming out. So I will stop here and let me see if there are questions coming on the channel. Okay, I think there is a lot of content that I see here. So one of the first question that I see is, what is AIOps? So hopefully you got some clarity. What is AIOps? It is a concept where we are bringing machine learning techniques and the broader AI capabilities to solve problems in IT service management domain. Okay, there are certain other questions related to career and other things. Yeah, I think this will be definitely one area which you can focus. It could, depending on your career aspiration, there are several paths through which you can travel, right? It could be you getting into a state where you are becoming a machine learning expert who is continuously analyzing the behavior of IT systems and IT service management domain, and you are able to come up with newer algorithms that will help IT service management to improve. That's one example. The second example could be you can focus on something called site reliability engineering, where you will be both a consumer of the AI and sometimes a contributor to that AI system, and you will be really solving a real life problem using this capability. And the third category, of course, is you could go into a product company where you are using your knowledge to develop a product and then help market that product. So this is definitely one of the important area with respect to cloud computing and IT service management. AIOps is a very, very hot thing in the market, I would say right now. So it's definitely an area I would recommend you to focus and contribute. I don't think there is any other specific question apart from what we discussed. Balaji, can you hear me? Do you see anything else that we need to address? I think the key questions I've addressed. And as I said, I'm happy to come back and give another session where we can go into details of some of these concepts. We could even go through a live demonstration on how this is working. We can take a sample application, demonstrate a failure, and then see how AIOps or the AI concepts are helping to solve that problem faster. Unfortunately, we are running short of time, so I'm not able to do it today, but probably we can have a subsequent session. Balaji, are you able to hear me? I hope the audience is able to hear me. I will wait for a few more minutes here to see if there are more questions getting posted in the live stream. And meanwhile, hopefully Balaji or one of the moderator can come back and we can conclude the session. Thank you, everyone. I hope you found it useful. Okay, so I see a question. What is the best ITSM tool? If you ask me as an IBMer, I will always say IBM tools, but jokes apart, there are several tools and several good tools in the market. And one other important thing, actually it's a good question because I should have mentioned one other point. If you look at the diagram here, let me bring it back. On the left-hand side, you can see several types of targets are monitored and we are getting events. And you can see various boxes here in the collect vertical, like log collection, ticket data, metrics, topology. So you will see in the market, there are some specialized tools. They focus in some of the boxes specifically here, and they do extremely good job. And every product vendor is bringing AI capability into their tool. So always it is not necessary that into a central AI system, you have to blindly ingest all the raw logs, for example, and then only you can get that anomaly detection. Often what is also possible is in the edge or peripheral log collection system or log aggregation system, you often have certain built-in machine learning capability. You could turn that on, and then that system can just give you the events or anomalies it is able to detect. And then when you feed that into a central system, the value that you are getting is multiple such events coming from various such boxes here. It can correlate that, and you get that Uber view about the environment. If you rely only on one box, you will get only a constrained view. Like if you focus on ticket, it may tell you what's happening with respect to tickets that is getting raised in a system. It may not tell you what is happening in terms of topology of a system, what's happening with respect to the metrics data that is coming, and so on, right? But if the ticketing system has a built-in AIOps capability, that will help you to process that fast and then feed to the central system. So now the central system only need to intelligently correlate that with the data coming from other system, and the time required to process the data and then correlate is definitely reduced. So we call it as edge analytics. Wherever such peripheral systems or edge systems are providing AI capability, we call it as edge analytics, and multiple the data coming or the insights coming from multiple such edge system, we can correlate in a central AI system to get that overview and then take the appropriate action. Okay, I don't see any other question at the moment. Okay, I see another automation. Sorry, another question. Let me read the question. Let me expand it a bit. Okay, so there is a very good, interesting question. So the question is, there could be some limitation in the automation. For example, development time is way more high than testing of systems in software architecture. And is there any automation or method that can overcome this limitation? So I think this is really contextual, because we also see the other trend, and everything is not strictly technical, right? So for example, we have seen several examples when we work with clients. Often the development of a small capability, as an example, takes 2 weeks to develop, but testing that and confirming that it is working is taking 3 months, because there are several stakeholders who need to come in, test, and give their input. So it's not really a technical problem per se, but it's of a logistical problem, right? So that is where more and more test automation is going to help. Similarly, from a development perspective, there is a big trend in the industry where things are moving to a low-code scenario, which meaning instead of you writing a fresh code every time, you will get a lot of functions readily available, and you can consider it as a Lego block in your solution. You just need to assemble them to create that composite solution. That will drastically improve the time required for development. But this is not really an AI-based thing. But if you look at AI, what AI can help there is, there are solutions which is now providing intelligent recommendation on, okay, what code you should write. Sometimes even providing you some prescriptions. By translating your business requirement, there are tools which can read your business requirement document and then recommend you certain functions or certain modules that you could use. So that actually accelerate the development time. And also, even though it is a testing activity, there is something called unit testing that's not really separate from development, because every developer is supposed to test what they are using. If you are following concepts like test-driven development, TDD, you are supposed to first write a test case, then write the code and check against your test case and see if the code is working fine. So in those situations, if you have an AI-based system which can use natural language processing and other machine learning techniques to read a requirements document and write your test case automatically, and then help enable you to give you some recommendation of function that you can use and produce your code, that will definitely accelerate the time that you're going to take for your development. Hopefully that gives you an example of how this can be done, but there is a lot more work happening in this space, which will give you better outcomes. As I said, the Lego blocks that you can just consume and create a composite solution very quickly. Okay, so there is another question. Is AIOps mean IT ops, DevOps, and SecOps? It's not really that way. I will coin it in a slightly different way. So IT ops, security operations, which is called SecOps, development operation, which is often thought as doing something on the development side alone, like CI/CD, continuous development, continuous integration. So DevSecOps, or sometimes even called as BizDevSecOps, is the end-to-end view of lifecycle of a solution, starting all the way from understanding the requirements from the market, continuously planning what capabilities we need to roll out based on a roadmap, then moving into the design phase, moving into the development phase, testing, deploying, and then operating. So this end-to-end is called DevSecOps, or sometimes BizDevSecOps. Now, AIOps is not related to just one phase of it. Think of AIOps as a technique that you can apply anywhere in this life cycle to optimize and improve and get value faster. So as we discussed, in a scenario without AIOps, if you are doing or performing IT ops, you will take much more time in today's modern environment to detect and resolve problems. But AIOps is a technique that is helping you to do it at a much more rapid pace. So still IT ops as a concept exists in that scenario, but AIOps as a technique accelerate that practice. It's the same way for development, it's the same for SecOps, right? In case of a security scenario, can you have a threat management system, which is using machine learning capabilities, predicting the threats that you may be having, and then helping you to resolve them in advance so that you are not working against a breach, data breach kind of scenario, but you are proactively fixing it before you release your solution to the market. I think there are a few more questions coming up. Okay, so the next question that I see is in the machine learning image classification problem, how to handle an unlabeled data. So so some of these areas are still evolving, but there are techniques called computer vision through which we can read images, we can match the pattern based on historic data, and then you can predict at least what is there, and also based on the feedback that you're getting from the users of your solution, and bringing the retrospective learning to improve. So there is already a lot of algorithms available. It is called computer vision, where you can read images and you can understand what is there in the image. If you use things like Google Lens, many times it can tell you what you are scanning through your mobile phone, right? So that's an example how you are doing it, where you are not really labeling it, but based on pattern recognition, it is able to detect. Yes, automation is the next question is future is automation. Absolutely. Everything is going to be automation. And if you really look at the interesting saying from Google, I talked about site reliability engineering, which is a practice pioneered by Google. And the objective of a site reliability engineer is twofold. When an issue happens, go and solve the problem and also make sure it does not happen again. Now, if you build on top of that principle, what is the ultimate goal of a site reliability engineer? Eliminate site reliability engineer itself, right? Because you are envisioning an autonomous system which is now able to run itself without requiring a human. I think it is a distant dream at this point, but as I said, if we can go at least 60-70% closer to that, we would have done a very great job. I see a couple of other questions as well. Give me a minute. Okay, I think that's a repeat question. It's already answered. So I think we will conclude the session here. I will stop sharing now. Hopefully it was very useful, and I will look forward to connect with all of you probably in a different session at a later time. Thank you, everyone. Bye.